So I needed a disc sander. I didn't really want to buy one, and I had a whole bunch of junk laying around, so I built one. Pretty functional. The motor was the old 220 motor that ran my air conditioner blower fan. It had a 7/16 inch shaft, and I was able to find a 7/16 inch pulley, which I bolted to a disc, and I used the power of its motor with some of the lathe turning tools I got hidden in the corner to make the sanding disc wheel. And I bought these 12-inch pads, sanding pads, that have the adhesive peel and stick, which work really, really good. So the 220 motor has been rewired to make it a 110 motor or a 120 motor, but this particular design needs a capacitor. So I got a supercapacitor somewhere hidden inside of this piece of junk, which I'm going to remove and show you how. So there's nothing safe about dismantling a microwave. Very, very little at all, actually. And the capacitor may or may not be charged. And they use a high current, high voltage current in these. So you're going to need to discharge the capacitor before you do anything in there. Although it's unplugged and shut off, it still may and probably does carry serious voltage. So the old timers used to take a screwdriver and put it across both sides of both terminals on the capacitor, which would cause a big pop and a big spark. That's very dangerous. If you're working in a commercial building or industrial building and you don't have a hot works permit, you can't go around shorting things out, creating sparks. So you simply just take a wire. In this case, I took a wire and I put a nail on one end and I sharpened it so I can use it as a probe. It's insulated, alligator clip to ground on the other side, and a little bit of shrink wrap insulation on that. And in the middle of it, I put a 20 kilowatt resistor, and that will allow the capacitor to be discharged and not create a spark. Also, you've got to be very careful inside these microwaves because there is some rhodium, and rhodium is extremely hazardous material. There's no cure for it. If you inhale it, you die. So you got to be very careful with that. There's a more chemically defined definition of it. Calling it rhodium is just a short way of getting by that. And this is a sample of the resistor used in the wire. You get one of these kicking around. They're about 40 cents if you need to buy one on the internet. Amazon, great place. Also, you got to be very careful with these sharp edges. They just stamp this metal out, and all the edges are extremely sharp. But there's a lot of great stuff in there. There's a couple of beautiful magnets that are really fun to have hanging around. Here's a sample of one of them. There's two of them in there, like that. There's at least two, possibly three brushless motors. Brushless motors have been around for a little while, but I believe it was Nikola Tesla who first conceived the idea of, instead of a static winded armature spinning around inside of a magnetic field driving devices, fix the armature to the device you want driven, and then put a circular magnet in place of the stator windings, and the circular magnet will rotate with the housing. So, in effect, no brushes. Magnet spins on itself. Pretty great idea. They use it in a lot nowadays. You find it everywhere. Taking apart DVRs and salvaging components here and there everywhere. Oh, well, enough talking. Let's get to work. So here it is, taking it apart. I got the transformer out and the capacitor out. There's a rather large diode connected to this one. I don't know why, and I actually don't know that that is a diode. I'm going to not assume that it is until I look that component up and find out what it actually is. But we want to discharge it before we go any further. And I was wearing gloves when I disassembled it, so I make sure I didn't touch anything. You're not going to see anything dramatic. There's no sparks, there's no nothing like that. So what we're going to do is put the cable on there, and I feel comfortable that that's been discharged, and it is. Okay, so now we can go ahead and disassemble this simply by pulling these connectors off. It's also a good idea for me to take a picture of that because I need to know what side is the primary and what side is the secondary. And rather than doing it with an ohm meter, I'll just take a picture of it and I will remember through the picture. Because I'm probably going to use the power supply for something else. Maybe I'll make a welder out of it or something. Who knows? He's still a little shaky because I know that these things really can give you a hell of a whack. Sometimes life-threatening voltages are involved. So we're going to go ahead and take the jumper. I'm going to connect the jumper wire to each side of the capacitor, and I'm going to store it like that until I get a chance to install it to the motor. In the meantime, I'm going to look up that component and find out what that is actually doing there. Okay, so these are the parts that we're after. We got them out of the microwave. Here we got a gear down ratio motor. This would be really good for one of the projects we're doing. We got 3 micro switches. These are great to have. You can use these in all kinds of crazy things. Little micro switches that click on and off during movement or motion. We have our capacitor, which has been fully discharged safely, and it remains connected together until I use it again. And that is a diode. It's a high energy diode. The high energy diode working with the capacitor delivers high voltage to the magnetron. Here's a controller. Now these are good because there's a lot of harvestable parts on here. You got a beautiful little mini transformer here. Got a nice relay over there. It's a 5-pin relay. We got a beeper. That'll come in handy. If you're using an Arduino, you can connect it up to that. Arduino, I have trouble saying that word. Got a little capacitor there. It's actually a super capacitor, so it's a big one. And we'll harvest this. We'll put this in our printed circuit collection. And as we need parts, we'll harvest them off of that. And then you got the Magnetron. The Magnetron is a very, very, very dangerous and very controlled device. Federal Communications, the FCC, requires you to have a license to connect this to anything other than replacing it in a microwave. And I believe in Rhode Island you need a license to repair microwaves. So you could be very, very careful with this, because not only is it use high voltage energy, and it uses counter magnetisms, and there's a screw in there, so I wonder if that's what caused it to short out. It has beryllium oxide on it as an insulator. Beryllium oxide is an extremely toxic material. If you breathe it in, it will kill you. Pretty simple. So what we do is when we take a magnetron out, first thing we do is we glove up, and then we put a piece of tape around that beryllium oxide, which is the purple material. Now you're going to watch some videos that people say that that's just ceramic insulation colored pink, but in modern magnetrons don't use beryllium oxide. Well, I'm going to tell you, I don't want to die. I don't know how old this microwave is, and I don't know if that statement is true. What I do know is true is beryllium oxide, extremely toxic, lethal. So you got lethal voltages coming out of a capacitor, lethal voltages coming out of a high energy transformer, as much as 20,000. I've seen 22,000 estimates as well, volts. And you got some very, very strong magnets in there. So now that we made it quasi-safe, we're going to disassemble this. It's going to kind of be a brute force thing. You're going to break these little tabs off and disassemble that. But that little piece of material on the top, you'll see, this braided brass material. I got one over here I use all the time. I use this as a heat sink, and I also use it to suck up solder when I'm disassembling. Nice little thing. I don't know if this is toxic, sitting so close to the beryllium, so I'm just careful with it. When I take it out, I'm going to rinse it off under hot water and set it to dry and put it up on my little shelf. So let's take that off first. They glued this one in. Alright, it's not going to come off in one piece. There it is. It's just pressed in. Now see how much contact I'm having with that insulator? If I didn't have the tape on it, we would be causing microparticles of that to fly into the air. just because of the contact. Alright, that wasn't glued in, it was just pressed in between the two layers. The last one I took apart just came right off. So I'll rinse that off under hot water a little bit later. Now we're going to get a heavy duty screwdriver. Gonna stop breaking joints loose, making noise, making sure we're not disturbing the wife, and take the rest of this apart to get at these two magnets. Okay, so now I wrestled it apart. Got that piece of tape on there protecting that. I tore it a little bit, so I put a little patch tape on it. When you pull it out, rip it all apart. First magnet come off, second magnet come off. They're just stuck on there. They're not even glued on there. They come right off. On the bottom of it, you will also find more of that insulator. That beryllium oxide. So we're going to go ahead and tape that over. Now, if you're really brave, you can pull these fins off, and there's a copper cylinder. And inside that copper cylinder, if you cut it in half, there's a really crazy design in there. That'll be great if you're doing some kind of an architectural sculpture. It can be used to make a nice accent piece. Also, underneath the bottom, you peel off the tabs. There's two coils. Some people drop that on your toe. Some people call these inductors. They're just coils with a piece of ferrite in the middle. Those look great too on sculptures. So you can just snap them off. They come right off. And this, throw away. And I'm going to save this, and I'm going to try to carefully remove these fins. And I'll cut that in half. I may use that in my next sculpture. But being very careful of that insulators. So set that aside for rainy day projects. Now we're going to get back to putting the supercapacitor into the motor so I can have the sander for my two wooden projects that are coming up. Okay, capacitor all installed, motor installed, power switch installed. Everything's looking good. Alright, a little bit of labor in getting it started, but it's a 220 motor running on 110. Once it gets up to speed, perfect. Exactly what we need. Now hopefully it lasts long enough until someone throws a wash machine or a dryer on the side of the road, and I'll harvest a motor out of that, a 110 motor out of that. I won't need all this craziness that's going on in the back of this. Okie dokie. Signing off for now.